Assalamualaikum. My name is Alif and my group member is Zul, Farid, Farhan, Amirul and Iqbal. Today I want to present about experiment frictional force. Okay, in this experiment, our objective is to determine the coefficient of static friction of different surface.
Okay, next I am going to explain to you about the theory of the experiment. Okay, the friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, which is the first one is static and the second one is kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by F static equals to mu static n Newton, where mu static is the coefficient of static friction and n is Newton, which is Newton is the normal force. For the second one, we have the kinetic friction. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by F kinetic equals to mu kinetic Newton, where mu kinetic is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plotted data, the coefficient of the static friction will be obtained.
Okay, for apparatus, this is wooden block with rubber cover at one side. Okay, for the second apparatus, this is 50-gram mass. For the third apparatus, this is 10 Newton spring scale. And for the last one, this is tabletop.
Now I will talk about procedure for this experiment. First, the mass of wooden block was measured and recorded as capital M. And for the second one, the apparatus was set up. Next, the tabletop was made sure stable and horizontal to the ground. After that, the spin scale and the wooden block was attached with a string, then was placed horizontally on the tabletop. The rubber side was made sure of the block was face downward. After that, a mass which 50 grams was placed on the wooden block. Next, the spin was pulled slowly. Once the block starts to move, the spin scale reading was recorded. The value as static friction force was recorded and tabulated in table 5.1. Step 4 until 5 was repeated for 3 trials, and another 50-gram mass was added on the wooden block, and step 5 and 6 was repeated. The steps was repeated until total of mass equal 50 gram. Mass is on the wooden block. Lastly, step 1 until 8 was repeated. This time, the rubber side of the block was made sure facing upward. The data was tabulated in table 5.2.
The next part is the result of rubber surface towards the floor. In this result, we can see that when mass increase, the static frictional force will also increase. This shown that the relation between mass and static frictional force is directly proportional. This is because when mass increase, the static frictional force will also increase. Okay, the next part is the result of non-rubber surface towards the floor. In this result, we can see that when the mass is increased, the static frictional force will also increase. This shown that the relation between mass and static frictional force is directly proportional. This is because when we increase the mass, the static frictional force will also increase.
So for analysis part, there is 4 things that we should do. First, draw and label the free body diagram of the wooden block. Second, plot graph of static friction force against normal force for the rubber surface and non-rubber surface. Third, use the gradients obtained from the graph to calculate the coefficient of static friction for each surface. And fourth is compare and discuss the coefficient of static friction obtained. For the first analysis, this is the free body diagram of wooden block that we have drawn and labeled. Next is second analysis. As you can see, this is graph of static friction force against normal force for the rubber surface. And this is for graph of static friction force against normal force for the non-rubber surface.
This is how we calculate gradient for rubber surface, and gradient is equal to coefficient of friction. Okay, this is how we calculate gradient for non-rubber surface, and gradient is equal to coefficient of friction. For the last analysis, coefficient of static friction for rubber surface is greater than non-rubber surface. It is because rubber surface creating higher coefficient of static friction than smooth surface.
Next, I will continue to the discussion of this experiment. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction. First is static, second is kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by Fs max equals to mu s Newton, whereas mu s is the coefficient of static friction and n is the normal force. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by Fk equals to mu k Newton, whereas mu k is the coefficient of kinetic friction and n is the normal force in this experiment. The frictional force between a wooden block and a rubber surface on a horizontal and inclined plane will be measured, and from the plotted area, the coefficient of static friction will be obtained. Friction is the force resisting the relative motion of any surface and material element sliding against each other. It is assumed that the frictional force is proportional to the friction coefficient. In addition, moving a particular item at rest requires significantly more force than moving a moving object does. We may say that kinetic friction is larger than static friction for this reason.
So conclusion for this experiment, as we want a more accurate result, this experiment may be improved if we use more two trials. Additionally, as seen in table 5.1, the coefficient value is higher than the data in table 5.2. This proves that the surface might affect the block motion based on the frictional force that was measured. Last but not least, because we require a force to move an item, static friction must always be bigger than kinetic friction. Friction force is a key factor in moving an object from a static state.